Okay, and next up we have Kruszynska, who's going to talk to us about Omega as a pathfinder for LSST follow-up.
All right. Oh, okay. Device. All right. Hello, everyone. My name is Kruszynska. I'm a postdoc at Las Cumbres Observatory, and today I will talk about a TOM or a Marshall system that we used as a pathfinder for LSST follow-up and what came out of it. So first of all, what is our motivation? It's gravitational microlensing. And because this audience is probably not very familiar with it, I will describe it in a short bit. It's an effect of general relativity when we have a distant source and which is usually a star in our case, and a lens, which may be star, may be something that is not luminous. And as it passes, in and out of alignment with the source, like in here, it produces a very characteristic symmetrical light curve that it cannot be reproduced by any other phenomenon. And my video was not working. It's fine. Why do we care in the case of Rubin? Because it will detect a lot of them. We estimate that it can observe up to 10,000 microlensing events per year, which is a lot compared to modern day surveys, which detect about 2,000–3,000 of those. It is, however, a very rare phenomenon, but it allows us to detect non-luminous or very dim sources, such as exoplanets, brown dwarfs, or black holes. So Rubin, with its intermediate cadence and like wide area, large-scale area, is perfect for detecting those phenomena. However, they will be all hidden somewhere in the 10 million alerts we receive every night from LSST. So that's where we need to deploy systems that are called target and observation managers, or Marshalls. And this is an ecosystem for where the microlensing Rubin Marshalls exist, exist. So first of all, we have microlensing observing platform MOP, which it works, which exists in here. And then we also have another MOP that I will talk, another TOM that I will talk later on. But the principle is just like Dan has shown earlier. So we have alerts that go through brokers. We have surveys that may produce alerts through brokers or through other means. And then they are ingested by our Marshalls or TOMs. Our TOMs do something with them, and then they send observing requests to other facilities. Microlensing is actually a pioneer in this field because a lot of building blocks that are used in these systems have been done by microlensing since the end of 1990s. This includes anomaly detection, for example, checking if your event is a typical one or is doing something else. Target prioritization to check like which event is the most important to observe right now, and multi-site observatory coordination. These technologies have been transformed by modern large-scale surveys, and that's where the microlensing observing platform comes in. It's a TOM or Marshall that is operating with the Omega Key project, which has been awarded by a substantial amount of time on the Las Cumbres Observatory network of robotic telescopes. It ingests targets from different surveys and alert brokers. It models them. It has capabilities to do event classification, target selection based on all the information it has. And then it submits observations to LCO network or other facilities, reduces this data, and then uses the reduced data to reprioritize the events, and everything runs in the loop autonomously. It can follow two types of events: long duration events, which are typically connected to black holes, or exoplanet events, which exhibit different type of variability. And this is an example of such an event. This event actually fell into two types of category. It was both a long duration event and an anomalous event. The MOP was following it first at a low cadence, which is typical, which we assigned for long duration events. And then once it reached the peak, the system is told, like, if the event passes several checks, it has to intensify the observations. And if you're lucky, like we were in this case, it caught anomaly which is connected to an exoplanet. In this particular case, we have detected a Neptune mass planet with an M-dwarf host, which is pretty typical for microlensing. Another system that I wanted to highlight here is something that was uses a lot of technologies we have first developed and tested with MOP. It's called right now the TVS Galactic Science OPM. It's a Marshall system or TOM that is developed as an in-kind contribution by a team at Heidelberg University in Germany. Its primary goal is to collect and prioritize candidate microlensing events from LSST. But it can also, in the future, would also look for anomalous events, for example, exoplanets. And it is also going to collect follow-up data, not requested, but collected, which is kind of important because here I show two important things that the Galactic Science OPM is going to do or is doing already. It's modeling microlensing events, showing these plots here. And then it uses the values from the microlensing model and additional values coming from different metrics or metrics produced by the alert brokers to combine them into a single priority that then can be used by users to filter out their favorite events. What is also important is that it collects the information, which means that in the case follow-up reveals that our event is not a microlensing event, then we can, this data can be used by other communities. When I was working as a PhD student on Gaia Science Alerts, a lot of our candidate microlensing events turned out to be YSOs or in some cases CVs. So we are working with these communities to share this data, and this system is going to be open to the Rubin community to facilitate the galactic science. And this ties into all of the effort that the Rubin TVS microlensing subgroup has been doing. As a part of the transient and variable stars collaboration, we have a small microlensing subgroup, which has done a tremendous amount of effort that these systems use. We have worked with alert brokers, both by providing a filter, for such in a case of Antares, but also like working with the alert broker developers to update or improve their classifiers. So in case of Think, it uses a software package called Michaelia, which has been updated by our collaborators. And with Alersi, we provide them with expertise and simulated data sets. In order to simulate the data sets for microlensing and other variable stars that may or may not look like microlensing, we are working with software developers, such as the link frameworks, software developers that produce the light curve links. And with them, we have built like plugins and wrappers for the software to simulate light curves. But we also generating the data sets, both as light curves, and also there is software that can ingest a microlensing signature on an image level. And finally, we are also coordinating proposals with other groups, such as primarily right now, we are collaborating with the X-ray binary groups because these like microlensing and CVs historically have been like each other's contaminants. And the organizers have asked us to answer certain questions. What were the lessons that we learned? And in terms of existing alert streams, I found, I and like my collaborators, we have found that using existing infrastructure such as MOP, for example, to test our software is very important to then like use this knowledge and like port it to other systems that we want to use, such as the Galactic Science OPM. But also we can use the, doing that reduces amount of time and effort required for development tremendously, because you already tested something, it kind of works on, let's say, smaller scale, but it exists and it's much easier to just update it instead of rebuilding something from scratch. The other thing that I wanted to answer here is how do you optimize the multi-wavelength and multi-messenger, transient discovery with the, with time domain astronomy and like multi-wavelength and multi-messenger alert streams. I think first it's very important to collaborate with brokers because this again cuts time on getting towards the goal that we want to reach. It is also very important to use the collaborative approach, not only in software development, because like multiple people have different expertise and they can contribute in different ways, cutting time on development again, but also in data collection. So we can collect the data and then share it with the other members of the community. And it's extremely important to have a platform, either use an existing platform or build a new one or something in between to share the data among the community members and give access to them. Because one person's trust is another person's treasure. So to answer the last question that I wanted to answer is, are we ready for Roman alerts from Roman? I think we are collectively. We just have to come together and like talk to each other and figure out what we know. And that's it.
Thanks. Questions?
Yeah,
I have a question. So I think we've heard about a lot of different people who are building TONs for their specific science case. Do you have thoughts on like with how you've worked with the brokers and stuff of like, how do we start talking to each other so that you can share your trash with maybe me, and that's maybe something I'm interested in? Do we need like a parent Tom or something?
Actually, I don't think we need a parent Tom. We just need an API that basically enables this bit. So in Tom Toolkit, but no, it's not only limited to Tom Toolkit, and it also exists like in Sky Portal and other things. Like there is a capability for the marshals to talk to each other. I think that's the thing that we need. So I'm a little bit worried about making everything centralized, because then you have to like make sure, like, first of all, you know, whose stuff is the most important. Then you also run into like hosting costs and everything else. And also I have been traumatized by losing databases at least once in my life. And like having multiple things that host the information is better than having one and then losing it, and maybe the mirror too. Yeah. So I think like what we actually need is just to ensure the communication between these different systems and making sure that people know about those systems.
Awesome. Question. Yeah.
Hi, Katarzyna, good talk. I'm just curious about those microlensing alerts and what is the plan to coordinate with other surveys that are also looking for microlensing, like both ground-based and future Roman?
Wow, that's a good question. We are, we as a, the TVS microlensing subgroup are working with very closely with the Roman, both ArgSpit and like the science collaboration on, writing proposals that help both communities, but also I think we should, maybe I'll just leave this point for this discussion. But I think we also have to think more widely about like what we need and what sort of thing we need. Like if a survey delivers X thing, we should not repeat it. We just use this and then maybe do a different survey that does something else. I'm not sure, sorry. Yeah, but it is a coordinated effort.
Yeah, I was also wondering like if some events will be You know, because Robin's observing way more than other ground-based telescopes. So do you have any idea of like the overlap of how many events Robin will observe with like, you know, basic like KMT, MOA, OGO?
Jointly, I don't know. The last simulations that have been done a couple of years ago. Oh, the right light is red. Maybe I'll wrap it up. Yeah.
We can discuss.
Yes, we can discuss this during the coffee break, maybe. Okay.
So actually, before you go away, we have a question on Zoom. Jennifer, do you want to unmute yourself and try and ask the room?
Actually, I can wait till you finish up and then I can ask. Also, Katarina, I would love to meet with you as well. Would you prefer to finish up and then I can ask or?
Sorry, I can barely hear you.
Okay. I would like to ask during the discussion session because I believe that you need to finish up. Is that the case?
We're about to move into a 15-minute discussion session. So do you
Yeah.
want to open the discussion session with a question to everyone?
That would be good. Yeah, thank you.
Okay, awesome. Is there
Do I?
yes. Does anyone know how to turn up the Zoom volume for the room? Okay, we're gonna try. Jennifer, give it a shot.
Sorry, I hope I'm not disrupting things. That wasn't the goal. So I wanted to actually follow up on Stella's question. So the one thing, and Katarina, please know that I don't expect you to be responsible for answering this question. I'm hoping to ask everybody. Is of course, yeah, that synergy between Roman and Ruben and really trying to facilitate that. So as the front line, right, of data products, right, MSOS will produce, at least on the daily basis, light curve catalogs. I'm wondering how we can kind of combine forces, right, to really truly provide a very, if not heterogeneous, but just a very composite data set for microlensing events. So do you have any thoughts, or does anybody else in the room? I just would love to chat about this. And by the way, thank you for a very good talk.
I have some thoughts, but maybe I am not, sorry. Well, one thing is just cross-matching, doing force photometry on Roman targets on getting a Roman target and doing force photometry on Ruben data. But that may or may not be limited by data rights and accessibility to the data because Ruben is working in data releases. There are other things. I don't know, but maybe we should chat about this later or like, asynchronously.
Awesome, thank you. Let's have one more thank you for all of our speakers.